Hello everyone and welcome to the Sario Dev Show. This is Engineering IRL. This is the show where I take you through ways to improve as an engineer and then also learn how to problem solve like a pro and be able to apply it to real life. So, this is episode 2. I'm just going to adjust my mic here a little bit. On today's episode, what we're going to talk about, or in this segment actually, is the 10 steps of problem solving. So obviously problem solving comes in many different flavors. Last night or yesterday I released a blog post about it. You can head over to the blog at Rev.2 if you want to check it out. Essentially what I do is I go through it's like the phases of problem solving. And what you probably typically know about problem solving, here's the thing, that I'm not claiming that engineering is the only career where problem solving comes into play. Basically all of life it comes into play. What we're talking about here is our profession, or the profession of engineering, is literally predicated on problem solving. So we learn many techniques to approach problem solving and troubleshooting and things like this. What you normally have is, so step one in any problem solving venture is identify the problem. But this is an important step because probably, I reckon, 9 times out of 10 the problem wasn't correctly defined, or what you thought was the problem isn't the problem. It's a very common case, easily can be overlooked. So it makes more sense the more problems you try to solve, that this is the case. But anyway, for now, let's say you have got you've identified your problem correctly. Good. Next step, and this is where experience comes in. You applied the troubleshooting steps, or the problem, or the typical solutions to the problem, the known ones. Obviously, this is going off like an arbitrary example of a problem. We're just describing it in general. Every problem has its specifics, but in general, for every problem there is a known solution, or typical solution, or whatever it may be. And the question is, have you tried those? So if your light bulb goes out, have you put in the new one? Those type of things. The known solutions, the known problems that everyone knows about. Okay. So that's the step 2, and this is typically where all problem solving sits. And your experts are the ones that know which of these known steps to use for your situation pretty quickly, because all they have to do is look at the scenario, and then they'll know which one to apply because they've just got that much experience solving the problem. So that's cool. But I said there's 10 steps. So how deep does this problem solving thing go? Well, it depends on the problem. The further and further you go down the problem solving track, the bigger it is. Hope for you guys is, if you're studying engineering, or you're studying whatever course it is, most cases you're really in 1 and 2. You're really in 1 and 2. If you understand the problem, you got the techniques you learned in class, and then you apply it. Half the time you get confused because you didn't realize what the question was actually asking. The other half is you get lost in your problem solving technique, or you just don't execute it properly, you make a mistake, whatever it is. But as long as and then obviously the depth of, the smarter students obviously know all the techniques that they have to learn for the appropriate exam. So level 1 and 2 of problem solving, most common. That will get you through your studies. Get good at this. It comes with experience and practice. Number 3. These things didn't work. For example, the light, you've replaced it, you've done all the stuff it still doesn't work. You need to check your basics. Okay, you need to check some fundamentals. What I mean is, in computing world, that's, have you turned the thing off and on again? That's it. You need to check your bases. In networking world, that's the cable. Did you check layer 1? Did you check that the physical cable is plugged in? Very commonly missed. Is the cable even plugged in? All these basics. Does your house have electricity? That's the basics. This is what I'm talking about. You need to go a step outside of the problem solving, outside of the problem, and see if a layer underneath has the problem. Okay? And usually, like in a uni environment or something like that, you don't worry about this step because that should be set. You're not challenged on, oh, is this really a math question? You're not really challenged outside of the bounds of the problem. Something else causing it, for example, because that's not the skill that they're trying to teach you. Anyway, so that's step 3. Cool. Going through step 3. We've exhausted step 3. I've got power, I've got electricity, I've got my basics. I know what's happening, I know where I am. Now you're at step 4. Step 4 is an easy one. Step 4 is do step 2 again. Repeat your tests. Repeat your knowns. Now that you've done your sanity check, repeat your knowns. For 2 reasons. One, obviously you tested already in step 2, but repeating the test might reveal different data. You don't want to really go like a 3rd or 4th time. You can. Because as I keep talking about, the further in the troubleshooting steps you go, the more and more expensive it becomes. A, because of time. B, because of the resource or the effort to solution ratio is pretty low. So anyways, now step 4 is repeat step 2. Sounds lame, but the amount of times that I've had people go through step 2, go through step 3, then call me over, and I come in, all I do is step 2 again. All I do is repeat one of their tests again, and it works, and I say, you're welcome. But obviously I didn't do anything beyond what they already did in step 2, but sometimes the repeated test really is all it needs. Maybe the first one is the anomaly. Doesn't apply in all examples, but sometimes it's worth a shot, just to really to get you to a certain state. Now here comes the more interesting parts. Actually, in the blog post, what happened was when I wrote this article, it's not like these are official troubleshooting steps. This is kind of just from my experience, the way that it's gone, especially after really problem solving in 1 and 2 and running into real walls that really have to extend again, and you get stuck. So, step 5, ask a colleague or a friend, phone a friend is really this step. The amount of times that the problem is just outside of that normal troubleshooting step, it ends up being something that someone knows that's experienced with it, can save you a hell of a lot of time. Normally you don't want to bug them until you've tried the earlier steps, because as a younger engineer, what happens is, even for really basic steps, you're going straight to step number 5. You're going, I don't know what this is, I'm going to ask. And depending on your task, that's either the right thing to do or the pesky thing to do. If you're really unsure or unsafe, or it's a really critical thing, then step 5 is always the way. But that just means you didn't have the experience to do step 2 in the first place. It's not really that you're up to step 5. Okay? So phone a friend, a senior, whoever it is. The thing is, if you've tried all the first few things, that senior that's going to help you will be more appreciative of that. Because typically what will happen is they'll ask you, have you tried this? Have you tried it more than once? And if you haven't done that, then you're already going back and doing the steps that I just said. So that's your step 5. Step 6, Dr. Google. Depending on the problem, if it's a commonly known one, this is almost equivalent to step 5, or if it's not for work or something like that. Google has the answers. You're still okay here. But if you're in an engineering field, you may be getting desperate here. It's kind of 50-50 at this point. Either Google has the answer and you're like, cool, now I know what to do, or there's like nothing on it. And you go deep, you check forums, you check chat message boards, you're signing up to things you never heard of. You're deep. You have no idea what's going on. You're still okay at this step though. You may, like I said, you got a 50-50 at this point. Okay? I think I have my numbers muddled up here, but it doesn't matter. Okay? I know you've asked Dr. Google. Nothing on there. Your next step, and this step is very, very commonly missed, and it's only when I got younger engineers heading into really their second year where this protocol becomes so obvious, but it's the RTFM protocol. Okay, when you're at these depths, you're at RTFM. And again, this doesn't guarantee anything because it depends, but the RTFM protocol is read the fucking manual. No one likes to do that step, that's why. Sometimes the answer is as plain as day, it's right there. It's right there. Make sure you've checked that step. No one likes that step. It doesn't always come up with a solution, but sometimes that's where you are. When you're at the depths of a problem that's just unsolvable, that's where you are, and that's what it takes. RTFM. Next, and we're getting a little bit of desperation here. This is now, you repeat the tests, but you change something small. Okay? Change slight things. Maybe the timing that you did it, maybe it was right after a reboot, maybe it was right, maybe if the way that you did the problem was at a time of day, number of people in the system, number of people around you, I don't know. You need to try, depending on the specific problem that you're solving, what you're up to when you're up to this step is really slightly changing the equation, slightly changing the input and seeing if that helps. So you're essentially doing step 2. It's a little desperate. Like I said, these go, as they go deeper and deeper, you're really looking hard for the answers. Not everything's abundantly clear. Okay? So, change the equation slightly. Change something else. Maybe you did it quickly, maybe you did a step slower. Any number of things. You know the process that you're trying to do. You know the problem you're trying to solve. If you're at this level, it's usually a multi-step problem at this point. Okay? We're not talking about one-step solved problems. They're usually solved in your 1 and 2. Let's just keep that in mind. So the next step that I have on there is pray, because you're deep now. There's almost no going back. Sometimes that's all you've got. Okay, pray to the electrical gods, the mechanical gods, whatever your problem is related to. Pray to those gods. And last but not least, this is it's almost like level 3, where you need to go to check your basics, but this is like, not only are you checking that you've got power there, you want to measure your basics. You want to run a multimeter there. You want to check if 0 volts is 0 volts. You want to check, if you're in the networking world, you want to get a packet sniffer on those packets and check at the packet level that's what's actually that's the way it's communicating. You're going below the protocol here. In a systems world, you're disconnecting your systems and you're testing a system in isolation, because those are supposed to be wrapped known packages. They should have known answers. If you're a programmer in the programming world, what you're checking is you're doing an if statement and checking if 1 is equal to 1. Forcing your if statement to go one way and seeing if you understand your logic. Because the thing is, if you're at these levels, okay, and let's say you want to work back up, but let's say you're at 1 equal to 1, and you get a false, you're in deep trouble. If you're at your very basics and things are just not right at all in any way, shape, or form, nothing relates to anything, nothing that you know about the world makes sense, nothing that you know about your life makes sense at this point, really, that's as far as you can go. You're at the point where this is game over. You just have to start again, rewrite from scratch, reinstall programs from scratch, rewire everything from scratch, rebuild from scratch. Whatever it is that is your problem, start again, because that's where you are. And sometimes you do that and the problem never even occurs, and you kind of go, why did it happen in the first place? 9 times out of 10, when you're at this point, the effort to answer ratio is not economic. You're never going to want to know, because it's irrelevant. It doesn't teach you anything, because how you got there in the first place could be the combination of so many things that would never happen again. And if it's fixed, it's fixed. in engineering profession, if it's fixed, if it's running, like, don't fix it, right? Don't touch it. Now, cool, congratulations, you found out the depths of problem solving and troubleshooting beyond the initial problem, beyond 1 and 2 that most problems have. You join the engineer world and the fighting and the digging that they get up to. I have a bonus step. This bonus step is a step in which I use daily, and especially when someone is in the depths of problem solving, where they're somewhere around 8 and 10. They've done everything. They've tried everything. They've done the early steps. They've checked their bases. They've repeated. They've done combinations. They've checked every known document known to man on the entire earth, all of its revisions and histories ever. They've asked everyone that they know on the planet. They don't know what's going on, and they kind of don't want to rebuild and restart again right now. Okay, they've spent already a stupid amount of time on this problem. They're not quite ready to rebuild and restart, because that adds a whole lot of other time. The other step that you have, and this is a step that I do commonly, that I thrive in, that I like, that's usually what I like to do when I come over and I help someone working on one of their problems and they describe it, is you test something seemingly unrelated to the problem at all. Okay, so what I mean, but let me unpack that a little bit, because I don't mean someone's got a technical problem and you say, have you tried tying your shoelace? It's not going to help anyone, but let's not go that far in terms of unrelated. It has to be within scope. You want to test something that may seemingly be unrelated, because and you know you're asking the right questions to, or starting to ask coming up with the right tests to try next, is when the person that's working on the problem and is this deep says to you, that shouldn't be the problem. Okay, that shouldn't be the problem, that shouldn't be related. And you ask them, you've tried everything that should be the problem. You've tried every fix that should be the fix. This is the stage where you're up to, where you should be trying things that shouldn't solve the problem, because everything that should have didn't. This is the Hail Marys. These are the clutching at straws. This is, I've got nothing left. And sometimes these are the answers. Sometimes, more often than not, it's not actually the answer. More often than not, it's not actually the answer, because it's pretty unrelated. But it does two main things. The first is that person now, with that train of thought of this thing that seems unrelated, expands his search on known tests. His level 2 tests, he's expanded. His level 2 and level 3 tests, he's expanded it. He's gone beyond, I better have done everything because I don't want to do this thing. What the hell is he talking about? The other thing it does is they've really exhausted it. They're up to here. They try these seemingly unrelated things, and something goes outside of the behavior they expected. Seemingly unrelated. Maybe this thing, this menu, this behavior has nothing to do with my thing because it's not exactly it, but it did behave abnormally. Boom, you have another clue. Now all of a sudden, boom, their eyes widen, like, oh, they have a whole other perspective of the tests to try. A whole nother slew, a whole nother combination of testing to try because of this one thing, and this different look. And these are unlimited. And lastly, sometimes it fixes it. And really what happens after there's forensics. You go, why? Because that shouldn't have been related, and then it ends up being related. So the purpose of this test, in addition, is all about trying to trigger your problem, okay, with different inputs, different scenarios, different things, to find a correlation in behavior. Some things will just not be related. You need to find a correlation. Okay, you need to find a correlation in order to start unraveling the problem that you've got yourself into. sometimes it ends up being the most basic of things, and sometimes it's the most difficult of things. But there you have it. That's the secret step. If you are the younger guy coming in and you've got a senior engineer and he's deep into, he tells you he's deep. You're not quite there to follow exactly, but he's deep into levels that he's thinking about just starting from scratch because there's no other answer. The only way you can contribute is trying to ask him some of these Hail Mary questions. Have you tried this, even though it seems unrelated, just to see the behavior? It's gold. You may help them in ways you don't even understand yet, but it's gold. It gets the conversation going as well. Sometimes all that person needs is to talk about the problem, and as they try to explain it, they kind of solve it as they explain it. Again, you're helping in that sense because you're just letting them come from a different angle. So that's pretty much it. This is obviously there's a lot of details in each of the steps, and if we try to apply it to every kind of problem, each step can apply. You just got to think kind of a little bit abstract. But everyday life, you can come up with it. You can use these kinds of approaches. You're not uninstalling your life decision, but you may be rethinking it. Maybe you come at a different angle. Even if you're trying to do a personal improvement thing, you are the system at that point. You are the system, and you've been trying all the known stuff. Like I said, level 1 and 2, you go, this is a thing I want to get better at. You try all the known stuff. Level 2s, you're trying all the stuff that you've heard of that you know should improve. You get to 3, you find out, like, am I even a person that can do these things? Level 5, you're Googling things. Level 6, you're asking people, asking experts, or you get some training. Most of the time you're good at those points. But when you're going deeper, you're start questioning why. Why am I even trying to achieve this? Right? Let me change the equation a little bit. Why can't I do this? You're going deep. Before you decide to start life again, change whole professions, maybe, just maybe, all you gotta do is try things that shouldn't be related. Do things unseemingly related. You as a human, as a system, are one of the most complex, or if not the most complex system known to humankind. So you want to be triggering as many correlations from your system to find out what it really wants or find out the real answers. This is where you can level up your problem solving and apply engineering thinking to real life. Alright? Hopefully this has been helpful to some or any or none of you. If it has been, let me know. If there are any questions, feel free to reach out. But as always, thank you for listening. I'll be back hopefully with another podcast, maybe on Monday, or if I find a random time that I'm in the car and I can talk about a topic. And basically I live off any feedback. If there's nothing, I'll probably keep trying because I find this pretty fun. Talking to myself, getting ready on the way to work and getting my brain turned on before I even stepped into the building. But if it is, that gives me some sort of direction and excitement. Can bring it to you guys or whoever is out there listening. But worst case, one day this will help someone someday, and if that person's no one, it might be me. So thanks again for listening. This has been the Sario Dev Show, Engineering IRL. Have a nice day. Hello and welcome to the Sario Dev Show, the Engineering IRL show, where I talk about engineering ideas, anything to do with engineering, and also how to apply professional problem solving to real life. So I did episode 1, and episode 1 went pretty well, I think. I managed to get through the drive and get through the topics pretty effectively. But I realized that the one thing that was missing was, well, who the hell am I? So I'm just an engineer, control systems engineer. I've been studying engineering since 2005 from high school. Had a fascination with computers since I was a little bit younger than that. Went through uni, worked an internship while working full-time, while working a side job, doing sales in a technical field, because in technical company, which was just tech products is what I mean. And basically I've been working in the control system engineer as a control system engineer for quite a while. I do systems, I do networks, I do software, app development, you name it. We do all sorts of kind of work. And in my side time, I like to experiment with a bunch of stuff. I do blogging, I do app development, all sorts of shit like that, because it's fun to try. Now I'm trying this podcast thing because I figure, why the hell not? The other reason actually is, well, actually there's maybe two reasons. The first reason is obviously in the it's a good practice, and this is for any profession, to be honest. Whatever profession it is that you do, and especially if you're in a technical field, your ability to communicate to all types of people, non-technical types, or management, or customers, or whoever it may be, because at the end of the day, everyone there has technical skills. You've got a whole bunch of smart people, a whole bunch of technical people. So the ones that can communicate the most ideas ends up having an advantage over the others. That's the first reason. Second one, so the first one is for professional career, just to get better at talking. Second one is actually, throughout my career, I've been in charge of teaching and training up a lot of newer interns and newer staff and things like that. And I quite enjoy it, actually. And I also found that it's good to kind of give back, because obviously for me, a lot of the early days I was learning by myself. Well, no, I had a lot of mentorship, but I did a lot of self-learning as well. So there was a lot of good stuff, and there was a lot left to be desired. So what I like to do now is obviously teach as much as I can. I like to help out all the younger guys learn, because I didn't have that myself. And lastly, it's to just start a conversation. I like to talk about technical topics, and generally in social circles and things like that, you can, aside from work and aside from talking with other engineers, you can't really have these in-depth technical discussions. And it's not even that technical, it's not like strict technical, but references to things that it just, even if I describe my job to people and to friends, it zooms straight over their head. So I know I can't really go in depth, because even when I just touch on the topic, eyes glaze over. That's pretty much it. But honestly, I think we do, as engineers, the coolest shit there is to do on Earth. And if you're an aspiring engineer, or you are an engineer, then you are one of the lucky ones. You get to work in both the state of the art in terms of technology and at the cutting edge of technology. It just depends on yourself. And this this applies to all fields. This is not just like computer engineering or software or things like that. Even mechanical, even civil, and all that sort of stuff. There is cutting edge technology in all of those fields. It's just up to you. It's just up to you to expand and to learn and to adapt to the new age of digital, essentially. So that's the other side of what I do. I do digitalization, OT, cybersecurity. I'm all over that as well. So hopefully what I can do is help anyone that's aspiring to be an engineer with their technical side of things. Anyone who's not and is listening, what I hope to bring to you is basically problem-solving skills that you can apply in real life, and might as well learn from the profession that's literally all about problem solving. So with no further ado, hopefully the audio quality of this is a little bit better. I just wanted to give a brief intro into kind of who I am and why I'm doing this why I'm doing this podcast. And I'm not even sure if I'm going to post this segment, but essentially it's just to, even for myself, iron out why I think I want to start the podcast. But the main thing is the conversation. So let's see where this thing goes. Maybe it's easy for me to talk whilst I'm in the car, because it really feels, it's like the car is like the one place where if you don't know how to sing, you can sing. So if that's true, then this is the one place where talking should come naturally as well. So hopefully this improves the quality. I got a little headset microphone this time. The first recording I just had on speaker, so it may not be as good. I'll listen to this later and check if it's worth posting. I might do I'll probably do the second post tomorrow, and if that episode goes well, I'll consider posting this one as well. My son is in the car with me, and by son, I'm talking about my son Jarvis. He's a Beagle cross Jack Russell, and he's sleeping in the back, so we got to get home. Thanks for listening if you are listening, and that ends the segment for now. Thanks and bye.